Mars, the red planet. For centuries, it has captured humanity's imagination, representing the ultimate frontier for science and exploration. But today, Mars is more than just a scientific goal. It has become a new arena for geopolitical competition, where the future of space leadership is being decided. The question is no longer just, what will we discover on Mars? But who will write the next chapter of human history among the stars? While the spotlight often shines brightest on NASA and its headline-making missions, a silent yet fierce rivalry is unfolding between two other space powers, China and Europe. Behind the scenes, both are racing to stake their claim on Mars, deploying vastly different strategies, technologies, and philosophies. And in this high-stakes contest, the balance of power may be shifting in ways few anticipated. By the end of this journey, you'll uncover three critical truths about the future of Mars exploration. First, how China pulled off an unprecedented 3-in-1 triumph, sending an orbiter, lander, and rover all in a single mission, while Europe grappled with a costly setback. Second, the radical difference in their search for life, with China drilling 100 meters into the Martian subsurface compared to Europe's more modest 2-meter approach. And third, why, despite years of effort and international cooperation, the Western Mars Sample Return Program has been pushed back until after 2033, opening the door for China to make history as soon as 2025. Let's begin with strategy, the foundation upon which every great mission rests. China's approach, led by the China National Space Administration, CNSA, is one of independence and comprehensive ambition. Every stage of their Mars program is planned, funded, and executed internally, with unwavering commitment and long-term vision. There are no outside partners to share risk or cost, but also no external limitations. This self-reliance has allowed China to chart a stable, incremental path, free from the political and budgetary turbulence that often besets multinational projects. Europe, on the other hand, has chosen cooperation as its guiding principle. The European Space Agency, ESA, is a key player in major international ventures, notably the Mars Sample Return, MSR program, alongside NASA. Here, the goal is to distribute risk and share the immense financial burden. But with collaboration comes complexity. Decisions are subject to negotiation, priorities must be balanced, and progress can be slowed by the need for consensus. The consequences of these choices are profound. The MSR program, once envisioned as a straightforward partnership, has been plagued by delays and ballooning costs, now soaring to an estimated $11 billion. Launch dates have slipped repeatedly, with a new target set for after 2033. Meanwhile, China's steady, autonomous planning has positioned it to bypass these obstacles, potentially seizing the lead in the race to bring Martian samples back to Earth. But strategy is only part of the story. At the heart of every Mars mission lies the technical challenge of landing and operating on a hostile, unpredictable planet. A gauntlet known as entry, descent, and landing, or EDL, this is where dreams are made or broken. China's Tianwen-1 mission marked a watershed moment. In a feat never before accomplished, China succeeded in delivering an orbiter, a lander, and the Zhurong rover to the Martian surface, all in their very first attempt. This 3-in-1 achievement stunned the world, demonstrating a mastery of EDL and mission integration that had eluded even veteran space agencies. Europe, by contrast, was dealt a harsh lesson during the ExoMars 2016 mission. The Schiaparelli lander, designed to pave the way for future surface operations, crashed when conflicting data in its onboard computer triggered a premature sequence, causing it to hit the ground at high speed. The failure was a setback, but the technical insights gained proved invaluable, informing safer designs for subsequent missions. Still, it underscored Europe's increased reliance on NASA's expertise for future complex landings. Beyond the drama of landing, the scientific focus of each program reveals even deeper contrasts. In China's Utopia Planitia, the Zhurong rover has been probing the Martian subsurface using advanced ground-penetrating radar. With the ability to image structures up to 100 meters below the surface, Zhurong uncovered compelling evidence of ancient buried beaches, bolstering theories of a vast, long-lost Martian ocean. Europe's priorities lie elsewhere. The Trace Gas Orbiter, TGO, has been scouring the atmosphere for signs of methane, a molecule often linked to biological activity. In a twist, TGO reported no detection down to exceptionally low levels, sparking debate and forcing scientists to revisit assumptions about methane's origins and destruction. Europe's next major step, launching the Rosalind Franklin rover, planned for 2008, will focus on drilling up to 2 meters underground, seeking organic compounds shielded from harsh surface radiation that could hint at past or present life. All these efforts are building toward a defining moment, the race to bring Martian samples to Earth. The Mars Sample Return mission is widely considered the holy grail of planetary science, promising answers to fundamental questions about Mars's history, geology, and potential for life. China's ambitious Tianwen-3 project aims to achieve this feat by 2028, leveraging its all-in-one architecture and lessons learned from Tianwen-1. In contrast, the international MSR program has been pushed to the next decade, held back by the inherent complexities of multinational collaboration. If China succeeds, it will not only be the first to return samples from another planet, a landmark achievement in its own right, but also deliver a geopolitical coup, challenging the technological supremacy of traditional space powers and reshaping the global space landscape. The implications go far beyond science. They touch on national prestige, international influence, and the very question of who will lead humanity into the new space age. Both China and Europe are indispensable to the tapestry of Mars exploration, each contributing unique perspectives and capabilities. Their divergent approaches are painting a complex portrait of our future among the stars. As the finish line draws near, one thing is certain: the outcome of this race will echo across generations, shaping not only our understanding of Mars, but also the destiny of space exploration itself. So, as we watch the final chapters of this contest unfold, the question remains: who will reach Mars's most coveted prize first? Who will define the new era of interplanetary exploration? The answer ultimately may surprise us all.